Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at today's homework for, or yesterday's homework, I guess, homework for 2.1.4. The very first part of it, the M&Ms, have to do with evaluating expressions and the order of operations. Evaluating expressions, remember, that's the process where you've got an algebraic expression, but we know the value for x and we know the value for y, or whatever your variables are, and you're going to plug those numbers in to the variable expression and then use the order of operations to simplify. So in this case, we would do multiplication first, then we would add, subtract from left to right. So 8 minus 3 plus 7, 8 minus 3 is 5, and 5 plus 7 is 12. Now, when you're doing the order of operations, sometimes students think that you have to add before you're supposed to subtract, which is a mistake. But one way to get around that is to use KFC. So instead of writing this as 8 minus 3 plus 7, if we were to do KFC and change that to 8 plus negative 3 plus 7, now you can add them in any order that you want because you're just adding numbers. That's the commutative property of addition. I could add the 8 and the 7 first to make 15 minus 3, or I could add the 7 and that's a negative 3, not a positive 3 because of the minus sign in front of it. So that becomes 4, and 4 plus 8 is 12. So now you can add them in any order that you want after changing the subtraction to adding the opposite. So I highly recommend you do that, especially when we're working with simplifying algebraic expressions. And then the order of operations. Remember, we've got parentheses or any grouping symbol. We've got exponents. Then you've got multiplication and division are equal partners of each other. So you would go from left to right when you're doing multiplication and division. And then addition and subtraction are equal partners of each other. So same idea, you would go from left to right when all you have is addition, subtraction remaining. Now in 7th grade, they talked a little bit about circling the terms, which is another approach that you can take, which basically when you circle the terms, what you would do is you would say, all right, this is one full term here, so you do PEMDAS within this term. Another term, do order of operations or PEMDAS in there, and once you simplify those two terms completely using the order of operations, then you will be left with just this, which you would go from left to right. Some people find it easier to do it that way. It's just pretty much up to you. Now, the grouping symbols, the parentheses aren't just parentheses. This is an obvious pair of parentheses that you'd want to simplify by multiplying first, and then 10 minus 6 gives you the 4. But this is another grouping symbol. The fraction bar is a grouping symbol. So this is telling you you've got to simplify what's in the numerator of this fraction before you do the division. And so fraction bars, parentheses, brackets, braces, there's the fraction bar, even the square root symbol. All of these qualify as parentheses or different grouping symbols. So as we practice this more, it'll be easier to remember and to understand. Problem number 41, can 0 be represented by any of these tiles? And here it's like, yeah, you could do two tiles. One of them is a positive and one's a negative being added together. So 1 plus a negative 1 absolutely works to make 0. Here with 6 tiles, you got 3 positives being added to 3 negatives. They would cancel each other out because you've got a matching number of positives and negatives. But there's really no way that you can have an odd number of tiles and get 0 out of that. Because if you had like 2 positives and 1 negative, you're going to be left over with a positive. You're not going to get a 0 out of that. Or if you had 2 negatives and 1 positive, you'd end up with a negative 1 after canceling out the 0. So you pretty much, you have to have an even number of tiles in order to cancel everything out and make zeros. Write and simplify the algebraic expression shown here. Okay, so always start with the original. You've got everything up here being added, everything down here is being subtracted away. So 2x's plus -3 minus an x minus a 1. Or, as I wrote it, minus the sum of the x plus 1. But if you use distributive property here, that would end up being -x and -1. Okay? Here you've got a y plus a -y plus 3 plus a -1. And then when you cancel out the zeros, that was pretty straightforward. You just, oh, I never really canceled these guys out, did I? So where are our zeros here? You got a 0 pair. That's the only one. You've got your x up here, and maybe you move these 3 down below, so it becomes x minus 4, or you move this guy up, and it becomes x plus a -4. Either one of those, x minus 4 or x plus a -4, would work. They're both the exact same thing. And then here you've got a -x minus an x and minus a 2, right? Or you can move these guys across the street, and this becomes 2 -x's plus 2 -1s. So there are a few different ways that you could write it. I guess the way that I've shown it here is if you move the x across the street and make that a -x, then this becomes, that is no longer there. 2 -x's minus 2. That's how I've got it written here. All right, evaluating expressions. Plugging in the value for x here. So you got 3 times 4 is 12, and 12 plus 2 is 14. So y has to be equal to 14. All right. Take a look at the answers. If you want me to work any of these out for you, just let me know, and I'd be happy to do that for you. Pause it so you can work through them and make corrections if you feel like you need to. Otherwise, let's move forward. All right, diamond problems. Remember, these two numbers, when multiplied together, give you the product on the top. So -4 times -7 is +28. And then when you add them together, you get the number on the bottom. So -4 plus -7 is equal to -11. In this case, this gets a little trickier because you're trying to find out what two numbers can you multiply together to give you -12 that when added give you +4. Now this is an interesting kind of a problem because you know if the product is a -12, then one of the numbers has to be positive and the other one needs to be negative. The question is which one is positive and which one is negative. This is where you find that out, because if the sum is +4, that means you were adding two integers together where you had one of them, the bigger one was the positive one, and the smaller absolute value was the negative. So you've got to have more positives and negatives. So if this was a -6 and that was a +2, this would not give you 4, it would give you -4. So this is the only way to write it. Now, you could have written the -2 here and the +6 here. They can be rearranged. That's not a problem. But it definitely has to have the negative sign attached to the 2, and the 6 has to be a positive. Okay? Go ahead and work through those. If you need help, you know what to do. All right, and now the perimeter of this rectangle is shown. If this is a 5 and that's a 40, this has to be an 8 since 8 times 5 is 40. If we know this is an 8, now we're not going to go there yet. This is a 5 times a 6, that gives you 30. And this is a 6 and a 7, so that's going to be 42. So if this is 7, that has to be 7, so it's going to be 8 times 7 is 56. So the total area is going to be the sum of all of these parts. For 86 times 57 is 106. No. That's not 86. This is 14, and that's 12, right? Because those combined are being added together, these sides and those sides. So 14 times 12 is 168. And then 12 plus 12 is 24. 14 plus 14 is 28. 24 and 28 equals 52. All right, if that went by kind of fast, sorry. I am trying to make this less than 10 minutes, and I'll spend as much time as you want. If you need to get a hold of me and we create a Google Meet, or we can just do it through email, or maybe someday in the future you're in class and we can talk about this more tomorrow. All right, take care. Bye.
Hey, feeling good, like I should.